seen it, if you looked at your mail over lunch, because I copied you, and made a point of saying, I kind of highlighted and said, right now, Rusty Bauer is a principal and former math teacher, and Lisa Scott, a middle school teacher and professional development consultant. And, I just tried to kind of give an idea of how many people are involved. And there's 15 people, there's 24 of you, and there's 15 people contributing to the material that's being presented to you, so I think that's pretty cool. And this is a good representation. And I also want to demonstrate their commitment, because as you saw, Cheryl is, 12 hours from having a baby. And Jordan is 4 weeks from having had a baby.
Yeah.
Doesn't he look great?
Okay, I'm Jordan Graves. I'm surviving on a diet of caffeine and debt. But yeah, we just had a little boy 4 weeks ago. So I'm teaching Reed Point, Montana. This is my 13th year teaching there. Yeah.
I'm Terry Dahl. I teach at CM Russell High School in Great Falls, Montana. I am 24 years after having a baby. Great job, you. This long to recover. So anyway, yeah, the youngest is 24. I've taught forever, but very excited to be here and share with you guys.
And I'm Brooke Taylor, and I teach at Billings Senior. This is my, I think, 9th year in teaching. Only my 5th year at senior. I taught down south before because my husband's military. So those are my 2 little munchkins that were clinging to me as we were walking around. So I brought some of my entourage.
We're here to tell you about statistics and inference. I ran into an English teacher last night, just walking across from Santa Fe Reds, and he said, "What are you presenting on today?" I said, "Statistics and inference." He says, "Oh, that sounds awful." So hopefully you don't think that, but it's going to be fun. We're gonna have some fun.
So, we need the data sheets.
No, not yet.
Oh,
Maybe
okay.
you should do
Oh,
that
yeah,
reading
start
part
this.
first. Yeah.
Yeah, okay. So the very first activity that we're gonna do is a little bit about Old Faithful, since that's pretty close to home for us, for most of us. So does anybody wanna share some experiences that you've had at Old Faithful? Maybe how long you've had to sit there and wait with your ice cream? Anybody have a mind-blowing experience at Old Faithful? Yeah.
My dad was actually trapped at Old Faithful in 1988 when the fire surrounded it.
Oh,
So September 8th, 1988, he was there.
wow.
So part of what I remember is we sat there and recorded, and we had it timed down for the 3 different news stations to record it on the VCR to get the fire sections of all the news stories from them.
Wow.
So
Very memorable.
Yeah.
Yeah. Wow. Anybody else? Yeah.
My daughter, when she was about 4, we were walking through the Old Faithful Lodge parking lot, and she thought that the coyote that she was going to go pet was actually a dog. That was pretty interesting. Pretty memorable. Yeah.
Oh yeah. What about right here?
My mother, when she turned 60, we went to Old Faithful, and at midnight, turning from 59 to 60, we jumped around.
Neat.
She could still do it.
And she can still do it. Cool.
Doesn't seem like that anymore, does it?
Anybody else?
One time, this is like 35 years ago before all the tourist stuff happened this year, and my dad loved taking pictures, and he got too close to a buffalo, and it charged him, and he said the only thing that saved his life is he remembered the rodeo clowns when they get charged by the bulls, they zigzag, so he zigzagged. He loves taking pictures, so he continued to take pictures. Pictures of like the buffalo charging my father. This was before I was even born.
Oh, I can just see that too.
Yeah.
Okay, so we're gonna get a little bit of background into Old Faithful before we actually begin some of the mathematical pieces that we're gonna do. This is one of my favorite things to do with students, and it kind of lays some framework for the task at hand, and especially draws in some students that maybe don't love math as much as all of us do, so that's a good thing. All right, so I'm hoping that each of you have a few people in your group. And so what we're gonna do is have each of you in charge of a piece of background information about Old Faithful. And then we're gonna do an activity with that. So I hope that these links will work for you. So if you would like to go around your table and just number off 1 through 4. And if you have less than 4, that's okay. We can make it work still. No, you want to, this is a link, so I would like you to have some sort of device, hopefully, with you so that you can do a little bit of reading. We're going to have to do some reading to get started.
This English teacher would have liked us.
I know, right? So if you're person 1, you're tinyurl.com, staff person 1, 2, 3, 4. So we'll give you a minute or 2 to get there if you need help. Once you're typing it in, if it doesn't show up, let me know. Or any of us know. We will try to make sure that you have access.
Person 4, you might, if it doesn't happen the first time, refresh it, it'll come around. I was looking at it this week, and the first time it wouldn't load. I hit refresh and it came right in, so
Oh, good.
yeah, it all worked as of. That's right.
Is everybody able to get them? Shorter than hit refresh.
All right, so we're going to give you a couple of minutes of silent and independent reading. So then what's going to happen is you're going to be kind of the expert in your piece of reading.
Stats first. Stats first. Second. Stats. It's like we do maths. We don't do mathematics.
But I know a lot of English teachers do like to use Jigsaw when they're doing reading exercises, so we're going to do that here. So what I would like you to do is you are going to share this summary with your group members. However, first, you're going to meet with the same people who had Article 1 or Article 2 or 3 or 4. So what we're going to have you do is grab your summary. You don't necessarily have to take your device along with you, but grab your summary. We're going to have all the ones kind of just stand up and meet up here in the corner and discuss key ideas. Make sure you cover all the key points of what you'd like to share with your group. You're only going to have a couple minutes together to just quickly discuss and decide what's the most important things to share. Because when you come back to these groups, you're going to have a minute to kind of give an overview of your reading. Okay? So we'll have 1s meet here. We'll have 2s here. Let's just have 3s be kind of a little further back. With person 1, then person 2, then 3, and then 4. If you're missing one of those people, we might have you just jump next to a group that if they have a person 4 and you don't, we'll just kind of go over and kind of listen to what they're saying. Because I know some groups might be missing a couple people if they had to step out. So I'm going to time you just for the sake of fairness. Everybody gets a minute. Okay, so you don't have to fill it, but you can. Okay, are you ready, person 1? You're so ready. All right.
Is a way of course, sharing with each other, but it gives you a chance, if you have students in your classroom that are jigsawing, so they each have a chance to, whether it's reading or working on a problem or whatever, and they get a chance to check with their peers before they share back. And so maybe I thought something was really important and no one else did, and so I missed the bus, or maybe they missed an interesting point that I really gravitated toward. So it gives you a chance to do that, get all on the same page, and then when you go back to your group to share the second time around, you're kind of all sharing the same information. And if anyone had a misconception, they get a chance to correct that before they share that with more folks and just kind of spread that misconception. So now reading these articles and then sharing and hearing, do you have a new perspective on Yellowstone National Park? Probably a little bit, right? Does anyone have some, like a light bulb moment or something that they'd like to share? It's okay if you don't.
Well, it was interesting, the fourth article, or the third article, the idea that we made it a national park based on the observations of a couple of white people, and we pretended that Native Americans didn't have anything to do with it at all, that it wasn't important to them, and then it became kind of a nightmare because there was all these conflicts going on, and we're like, well, how'd that happen? Sheesh, and we save it for white people now, and we don't even care about anything else. I never knew that was a history of behind a park that I visit regularly, so.
Yeah, yeah.
Well, I once took a class on Native stereotypes,
Yes.
and, it's not about this, but just stereotypes in general. There is a movie made in 1922, it starts with an N, I can't remember what it is, out of Canada, based on the Canadian Inuits.
Okay.
And how we associate that with Alaskans living in igloos.
Oh wow, okay.
Or, if I go to Alaska, for example, Alaskans may think that we live in teepees.
Sure. Yeah, yeah. This is Brooke's activity, and so she picked out great articles for this, and I did this last year and this year, and I read it over again and, recognize new things. So this is a great opportunity, obviously, to, you're doing a mathematical topic anyway, and so it's a good fit, where we're going to throw in there, and so, the misconception about Indian education for all is you need to design all new material. And a lot of you are doing the same stuff. You can just use native sources or native materials, or just educate people at the same time. And so it's kind of it's not a new thing. It comes side by side with what you're already doing. And the nice thing about preloading it this way is we're going to do an activity on Old Faithful, and you get a chance to educate folks, and then when it comes up with myths and stereotypes and people who have been or have stories they share with each other, and you have a chance to kind of get out in front of it, and so you're educating them ahead of time, and then maybe some of these misconceptions don't come up, and they kind of get them squashed ahead of time, and so they don't start sharing these things out or offending people, or yeah. So some things to think about during our task are what perpetuates myths and stereotypes, and what can you do in your classroom to disrupt that cycle.
Okay, what we're going to do now is look at some more things about Yellowstone, and of course Old Faithful, one of the main things that we see there. We take a field trip, I don't know what you call it, to Yellowstone every year. We take a group of about 30 to 40 kids, and we have a research permit there. If any of you ever want to do that with your kids, I strongly recommend you get a hold of them and see if you can get a research permit. You can put probes in all the pools and all that kind of stuff. But one of the last things we do is we go to, I think it's called the Omni Theater in West Yellowstone, and they have those different movies that they'll show. There is one about how Yellowstone came about, and it is fascinating. And it, of course, it's all staged and everything, but it shows them sitting around the fire and talking about a lot of people back then wanted to do it for profit and for big profit and that type of thing. And then it became part of the national park system. But it also portrays the Native Americans at that time. And I hope it does it correctly. I'm not certain if it does, but it's a great, great thing that I felt really tied in with what the articles that Brooke had for this. Okay, so you have just arrived at Old Faithful, and you pull up in the parking lot, and everyone is walking toward you. What just happened? Just Okay, you did, you missed it, and so now the question is, what do you do? In my statistics book, and I don't know how many of you use this statistics book, I think it's hilarious, but it's by Darren Starnes, so Yates and Starnes and more. It's the practice of statistics, and it's edition 4, and he does this. He said that, and unfortunately I think this is probably true about Darren Starnes, he and his family went to Yellowstone, they pulled up in the parking lot, and everyone was walking toward them. And he said, we had only budgeted for 4 hours in the park, and my kids are like, did he not read about the park before he came? And I'm like, no, I think he probably did, but he only had 4 hours. So the big dilemma was, do I stay and just kind of do some things right here, hoping that it will erupt sooner than later, and then I still have my time in the park? Or do I actually go and see some other things, and then what if I miss it? And what would happen then? So he makes a great problem out of it, and in fact, we're just doing it now, so my kids who just got off the Yellowstone trip, they like to work with this. But what we're going to do is we're actually going to give you some data, and we're going to let you come up with your answer to the problem. So if you look in your binder behind tab 6, you're going to see this data in there. Is everybody finding it?
Should be a table of.
I think it's toward the back of tab 6. It's probably right in front of tab 7. To be honest with you.
Yeah, the very last.
There you go.
So where are we looking, what tab?
It's this right here. It's this one right here. So it's this table right here that should be in your book. Oh, I'm sorry, yes. The practice of statistics?
Yes. What level are you using that book at?
It is for well, it used to be called statistics, now we call it honors statistics. The kids that we have that take it, we have it for dual credit. So because there are so many kids who need to take stats as part of their program.
So is it your book? It's the book that the kids have, or is it?
Yeah, the practice of statistics is the book that we use for that.
And that was Moore and what?
Moore, Starnes, and Yates. Moore, Starnes, and Yates. And I believe both Starnes and Yates write for the AP exam. Yeah, they're either writers or they run the grading section of it. Yeah.
Thank you.
Yeah, so, and they're great writers. They're both high school teachers, by the way, both of them. Moore isn't. Moore is probably the guy who wrote the book. Moore and McCabe wrote so many of the statistics books when I was in college, but that's not when we were in college, but hopefully they start around you guys. Okay, so here's our data. There's a lot of it, okay? One of the things I always talk about with my kids is the minute they get a set of data, they just kind of make up what it's about. And so I really have to work hard with my kids to read. This is the minutes between blasts. And then they want to use the 1 through 16 for some reason. I don't know why they do. But so what you have to do is you kind of have to, I think this is a great place when you're looking at data to really make your kids read and tell you what is this data about. So this is all you have, as well as the other things at your table. You can't Google it. No, that's not okay. So anyway, here's your data. And as each table, I want you to use that data and come up with how long, so you just drove up, everybody's coming out, how long do you think it would be before it's going to erupt again? So these are your minutes between blasts. We're gonna bring around some paper to each of your tables. Once you make your decision, you're gonna write on there how you came up with your decision, go put it up on a wall close to your table, and then we'll have you present on how you came to your solution.
Are the 1 through 16 just to like identify rows?
They're just to identify the rows in case you wanted to use that in any way.
And remember, justify your answer, provide a visual aid. Okay?
Excellent.
They're not 16 sounding sets?
No, no, it's just to number the rows is all. Yeah. That's a good point about it.
I was gonna do
Goes around and has you guys share out. A lot of you asked questions on the calculators and some of the things that the calculators can do. And they can sort the data from smallest to largest. They can find the min, the Q1, the median, the Q3, and the max using one variable stats. also your mean and your standard deviations. So I know, and they can do the box and whisker plots, but as long as you set your scale. And then these guys actually went through and wanted to find their mode, and we used a histogram with a X scale of 1, or bin width of 1, so that they could find that, which I thought was a nice use of that. So we're not going to show you all of the technology stuff because some of you are using calculators, some are using decimals, some are using all sorts of different things. So, but as you present, maybe you could kind of say a little bit about the technology that you used. Okay? So Jordan's going to have you share.
Before I start, working around the room, you guys smell fantastic. Just to let you know. Lovely, lovely. Not always what happened last year. You guys smell great. Oh, love it. I'm gonna ask this group to go first, please. Tell us, what do you predict? And then just kind of tell us a little bit why, and anything else that you think is cool to want to share with the group. Would you like to do a gallery walk first?
I don't know what they're talking about because I can't see that.
Oh, good point.
Yes! I would like you to take the next 5 minutes and do a gallery walk. Oh, I'm sorry, you're gonna go this way to go first. So, but yes, everything. Would you please be so kind as to share, again, what's your prediction, and then anything else that's relevant, and kind of what you did. Okay, that's fine. Tell us.
Well, we were just kind of joking around how Ron and I both identified ourselves as being Eastern people yesterday, but we kind of took a Northern approach today, just dove right in and started doing our intervals for a histogram, and on reflection, we would have done some different techniques. But that's what we did. Broke it into 10-minute intervals and calculated some chances of, like, if you left for 50 minutes, 60 minutes, 70 minutes, what are the chances that you would miss it. So, like for instance, if you left for an hour and came back, you'd have a 25% chance that you would miss it. So, depends on how much of a gambler you are.
And how much of the data did you use?
We use it all.
All of it? Okay. So if you were just to look at your picture there and you were to take a guess, what do you think?
If you were a degenerate gambler,
Yeah.
you had to put a number on it.
And I only gave you 30 seconds to decide.
Yeah,
We're not leaving.
40
minutes? They're not missing. 40 minutes. There we go.
So you think how long we'll wait is
40 minutes.
Depends on.
Write it down. 40 minutes.
That's what it is. That's what it was.
Yep. All right. And we're going to go right across the front.
All
Alright.
Oh, sorry.
Did you want to?
That wasn't really what we meant. We just meant we'd only leave for 40 minutes.
Okay.
You just misunderstood.
You want us to come up with a number of if it was going to.
How many minutes between eruptions? So if you had to choose one number. 40 minutes. What do you think? 72.
72.
But then why do you? If it's
Awesome.
only gonna
Thank
be
you.
16 more minutes.
Thanks, guys.
All right. This group.
Alright, we put all of our data into graphing calculator and made a box and whisker plot.
This you over here?
That's right there. Did you want, yeah, that's perfect. And then these two made a histogram. And then we collaborated.
Nice.
But what do you do?
So we said that the wait time had to be between, I can't read it from there. 60 and 83.
Was that the likely, the most likely?
The most likely. Between 60 and 83, with our median mean rate of 76, but we thought that they shouldn't be, because traffic was really bad on it.
So, can we put a range?
Yeah.
Okay, I think our range is between 60 and 83.
And how much of the data did you use? Did you use
All of it.
All of it?
All right,
Quality data.
group ice cream.
We took a little different approach. Since we had our kids and we were at the park, we weren't coming back, we were gonna make sure we saw it. So we just decided that as they were walking towards us, it probably blew about 10 minutes ago, which means a minimum amount of time based on the statistics is 33 minutes till it blows again. So we went to the lodge, got some ice cream and sat down in 33 minutes and we're gonna wait till the thing blows again.
Okay,
No matter how long it takes.
no matter how long it takes. But if you had to make a guess,
Our range is
An hour.
between,
an hour?
33 minutes and 58 minutes. Oh, yeah.
We're waiting an hour.
Waiting an hour?
As long as it takes.
Okay,
I mean, that's what I would tell my kids.
yes.
And, you know, if they're 4 or 5 years old, they have no idea what an hour is.
But they do have an idea of
And then
how
they'll
much
say,
ice
how many
cream
more
they can
minutes, and I
eat.
say, "Hour."
It's all why.
They still don't know how much time that is.
And how much of the data did you use when you got your numbers up there?
We use 6 rows.
6 rows. And how did you choose your 6 rows?
Start at the top.
First 6?
No, the first 4 and the last 2.
First 4, last 2. Got it.
Okay, ours, it was kind of interesting, these two ladies over here decided to we were typing the data into our TI-83s, and, they chose to find the largest and the smallest, and then to, actually find the average of the range. And then by the time we got it entered in, I missed 4 data points, and she got all of them. But we actually ended up, our average and median and mean, I mean, all of that same thing. Average and our median for all 3 different reference points was the same pretty much, primarily.
Wow.
So whether you subtract 108 and, or subtract 43 from 108 and find the average between those 2, or when I missed 4 data points and she had all 284, our median and our means were not much difference between all of them.
So we said we'd wait about 75 minutes, 1.25 hours.
Okay.
Great.
And then we all kind of come to the consensus, though, if you're there to watch it, and you're gonna wait anyways.
Okay.
And there's the gift shop, and there's the ice cream, and we would find something, and we would walk, and we would find something to do anyways.
Okay.
So, we randomly, did the random number generator, Wendy did on her calculator, and we started with number 5. And then from there, I decided to count by 4, so we just picked every 4 rows, so that's how we got 1, 5, 9, and 13 as our sample. And then we found the average of each row and the median just to kind of look at the 2 numbers, and then found the averages of both of those, just to look at those. So we said you'd be waiting about 75 minutes. And then the lodge is really pretty, so you could, take a tour of it. Wish you got your reservation sooner to stay there.
All right.
What was the number
75.
again?
75 minutes. About.
And our last group, please.
That's you, you can
Yeah.
statistics figure out. We wanted multiple representations, so they put all the data in because we had time and she typed fast. And he read her the numbers so that they could catch any errors, and we checked that there was actually 288 data points. But we didn't want to do a stem and weave to organize the data. I was gonna wait until she got them ordered and then do it, but I didn't want to write those out anyway, so that's why it says the leaves go here. But we have a box and whisker that I could start on while they were getting the information. And we did all of the quartiles, minimum, lower quartile, median, upper quartile, and the max. We also did, I forgot to put in the range, but we did mean, interquartile range. We decided there were no outliers. No outliers, and we found the standard deviation. We also, since we had time, went ahead and made the histogram, and then we also, from that histogram, we changed the scale to be 1 because we decided we wanted to find the mode also and didn't want to count. So we didn't have enough information from the question, to really decide how we wanted to answer it. So we got into it and said, well, if we only had a 20-minute window, because it's like, if we're gonna be there, we're gonna wait for the whole thing. But if we only had a 20-minute interval, we would pick 70 to 90 minutes after the first eruption, because the box and whisker easily tells us that it was between, I can't read my own writing, but, so we picked a 20-minute window, and that would be when I would pay to sit up front. You know, if I had to make a reservation, that would be the 20 minutes that I would pay for the seat. As far as how long we would wait, you know, there's a 50% chance that it's going to be a 23-minute window, so we would go ahead and go do something else, be there for that 23-minute window, and if it went off a little earlier than that interquartile range of 23 minutes, we would see it while we're walking up, and if it went off after, we would see it while we're walking away, but we would pay to sit for 20 minutes.
Okay. That's odd.
But as far as the answer there goes, if you want a range, we would go 70 to 90 minutes after the blast, which would be waiting because they're already walking towards us, 65 to 85. And if we have to pick an actual number, I would pick halfway between the mode and the mean of, so 75, since the last blast, minus 5 because it already went off. 70.
Okay. Awesome. I love the range of answers, and I think there's a lot of reading into the problem, which is really cool because it's empirical. It's empirical data. And yeah, this is a real life idea, and so you're absolutely right. I mean, if you're there, you're there. But and so I don't know. It feels a lot more rich. It feels a lot more like you bought in more than just like what's the average. You know, I give you a bunch of data and say what's the average, and you're like, well, what's the average? I don't know. And, you know, but yeah, you can really get in there and get dirty, and then play with it, and use all of it or some of it. What kind of data was it? What kind of histogram do you get? The word I'm looking for has two humps. Yeah, bimodal. You don't realize that when you look at it at just the data table, but when you graph it with the histogram, you see, oh, this is bimodal data, which is well, brings in its own interesting pieces here. There we go. Good. This is 2011 data. Before I hit that, do you think these predictions, if I said, when was Yellowstone Park established?
1872.
Thank you, 1872. If I said 1872, would you say 72 minutes or 68?
Less.
Less.
It erupted more often back then.
It erupted more often back then. Yeah. It's
Not according to this article, it didn't. The average range between eruptions has pretty much been steady.
Oh. You said it was increasing.
No, I said.
Sorry, I misunderstood.
That they were gonna further
I can't remember what I said.
But that wasn't it, whatever you just said it was.
That's not it. But I found the most interesting thing I just read was, and this is another math thing, is that the time between eruptions is related to how long the eruptions last.
Yeah. There's a whole other problem set that you can do.
You could, yeah, see what the
Yeah. Short blasts mean shorter wait time to the next one. Longer blasts mean you have to wait longer for the next one in general. And that's a whole other data set you can find, and yeah, Old Faithful's very, very rich for that sort of thing.
The other thing this guy says is that, contrary to popular belief, sitting in the front row is not the best place to observe the geyser. and to appreciate how big it is, that you need to be further away. Perhaps on the top of Kaiser Hill.
My learned friend also said it's going 2 minutes longer between weights every year. You told me that.
For the whole year.
Yeah.
But that's not very long.
No.
I mean, it's not like.
Right, but if we roll back to 1972, right? Yeah.
And what's kind of neat about this data, I think when we were talking about it, we found it before, but it came from an NCTM stats book from, I don't even know what year, I don't want to say because I'll be wrong, but, so we think it's consecutive blast data for about 2 weeks, but we don't want to tell you that necessarily because we don't want to bias your
This
data.
information I was reading was from the AAA official site.
So you could also look at the data, if that was consecutive 2 weeks, what is it in January versus February, and it's probably.
And there's a whole website too that we pulled that graph from that has Geiger data, which is pretty cool.
Quick question for either I guess Jenny. These PowerPoints are gonna be up there so they can hit the tiny URLs to get the articles.
Yes, they'll go up in PDF form, but I think the PDFs still have live links in it.
Okay, yeah.
If you just remember what you were stats, it's tinyurl.com/statsperson 1, 2, 3, or 4.
Cool. Okay, well, of course, what would Old Faithful be without ice cream? As we listed, we planned this because we knew you were gonna talk about that. Go to your binder again behind tab 6. Behind tab 6. Oh, yes. Okay, we're only going to give you about 5 minutes. Oh, I'm sorry, this is what you're looking for behind tab 6. This little graph, it's in yellow. Okay. So you have about 5 minutes at your table to look at that graph. And then we're gonna go around and ask you why you think there's the relationship that there is there. So it definitely shows a relationship, right? Anybody know what kind of relationship that is? Positive, right? Positive relationship, okay? And so, take about 5 minutes and decide why you think this is a positive relationship. Ice cream is on the X, and on the Y, which is your dependent or your response, is drowning deaths. So, which table wants to go first? Why did it happen? Yes.
Well, when you consume more ice cream, it's usually summertime, there's more people this morning.
Okay. Another one? Yeah, that too.
No, I want this group. What did this group say? Yeah, what did you just say to Brooke?
About our alternative?
Yes.
Yeah.
So, I apologize in advance. Maybe people who eat lots of ice cream are obese and therefore they're not good swimmers.
Guys, if they're obese, they have a higher fat content that would float.
It's not like a built-in life vest.
Oh,
They would get winded and cramped,
So who else? It's not a valid question?
True.
There's a thought. How about you guys? What do you think? Oh, you were the same, right? Did we get yours?
My only other thought was that you're too distracted eating ice cream that you drown.
Oh.
You're eating ice cream
While
while
you're
swimming.
You guys?
You never know.
I walked up to the beach, they so good. Okay. Well, I have to say, it was pretty humorous when we did this last year. The reason said that nobody went straight for that it's summertime thing, which just cracked me up that they were all coming up with these crazy
Are you
ideas.
serious?
Yeah,
Were
no,
they
because
just being
they were
on
funny.
purpose?
Oh, the stories were so funny what they were doing. But yes, absolutely what's happening here is it has to do with something else. And the something else it has to do with is the time of year, temperature, and all of that. So in statistics, we call that a lurking variable. So we often see relationships between two different sets of data, two different things that we're looking at that really have nothing to do with each other. It's this lurking variable out there. And so we just think it's a cute thing, and so that's why we did it. Okay.
Is it spurious correlations?
Yeah, yeah.
So if you ever seen the website Spurious Correlations, they just graph a lot of this, which is completely just they've gone through stacks and stacks of data and found things that correlate. They're ridiculous. Like
one is like release of Nicolas Cage movies versus drowning deaths. You kind of think like, oh well, most movies come out in the summer, but I looked at it and it's like, no, just freakishly the movies. Like one summer we'll have a Nicolas Cage movie, tons of drowning deaths. The next summer, no Nicolas Cage movie, like drowning deaths have gone down.
Spurious correlations. SPURIOUS.
Like curious.
Vegan diaper.
Correlations.
Where do you find out website?
Correlations. I believe spurious correlations.
Yeah.
Yeah. So
Maybe
sorry, that's
Google
kind of
that.
tangent. So.
Yeah. I'm still on there with markers.
Well, I think those spurious correlations make your kids think.
Right?
And instead of just spitting out what we're spooky,
So we just saw an example of a regression line, and it looks like there's a relationship there, right? So does a relationship mean inference? Not necessarily, right? And so that's something we have to be really careful about when we're talking to students about, because sometimes they can take that and run with that, right? Oh, there's a positive relationship. They're related. That means one infers the other, right? It's predicting the other. So you have to be careful, I think, with the situations that you use with those too. And so that's why it's kind of interesting to think about the ice cream problem also. I thought it was interesting with the Old Faithful data that nobody actually did a linear regression. I was like just hoping somebody was going to do that because that's where we were going, kind of. So, but that's okay. That's okay. Nobody did last year either. So you took a look here at positive relationship. You have a regression line. And so a lot of what we're going to be doing when you get to our online module on statistics, we'll be talking about some regression. And so we're going to have an opportunity to let you work with that and get familiar with the calculator steps if you aren't already. So that's what we're going to take a look at today. Okay, so right now you have a roll of paper towels on your table. Okay, so at your table, you should have paper towels. You also should have yardsticks either on your table or near your table. Yeah, okay. So we want you to take the wrapping off carefully, kind of see how I ripped it on the top. You want to keep it intact maybe for later. Okay, so we're going to keep it. And you've got your paper towel roll. So we need somebody to fold a yardstick across the center if you can. And what we're going to do is we're going to draw a radius on our paper towel, not necessarily all the way across. Yes. So we want to put roughly in the center, and we're going to mark. Ooh, yeah, line up with my first towel. That's right. Okay, I want to line up with my first towel. Thank you, Jordan. Couldn't have an issue there. All right. He is.
I wasn't like clairvoyant.
So then I'm gonna make my mark, and I want to get it kind of dark because I want to be able to see it into the other paper towels, not just the first one.
Dark but not too thick.
Yeah. So like this, mine's probably a little bit too thick because mine was kind of not very dark at first.
They can just use one side of the other.
Okay. Yeah, so you want to make sure that your marker soaks through that, the kind of the top layer of paper towel.
And that marker too, you can make it skin like that.
Terry Dahl original lesson. Make sure we line it up.
Good call. We found the use of bad maca.
Yeah.
Good, get your.
Okay, so now what we're going to do is we're going to gather some data. So we're giving you a couple of different opportunities to gather data here today. Some of you in the last activity, you used every data point we gave you, okay? Your values that you entered in, you could do any type of one variable statistics that you wanted on it. So now we want to move on to two variable statistics. But we're going to tell you what you're going to use. So for our purposes today, what we will do is the number of racks will be your explanatory variable, or your X, or your independent, whatever you want to call it. I try making my students in statistics explanatory. So a RAP is the distance, is once around, okay? And then for your response variable, or your dependent, or your Y, we want the distance, the circumference of that. So you're actually gonna unwrap your paper towels, okay? And so with your marks, just make sure you always measure off the same side, okay? So if you go off the close side, always go off the close side. Just because there's some thickness there, and you're gonna find as you unwrap it, there's not a huge difference, from each wrap that you have. So that's why you kind of have to stick with where you're at, okay?
So this will be wrap 1.
Right. Good.
So each sheet is a wrap.
No, each circumference is a wrap. Okay, so what you are going to do is you are going to probably get down on the floor. You're going to unwrap those paper towels. You're going to start measuring. You cannot measure the whole roll. Party foul.
Not
Cannot do
efficient.
that. No. So you're going to have to decide how many data points are you going to take. No, okay. You have to decide how many data points you're going to take. We've been talking about this, trying to decide how many. So how many data points? Like I said, do not use the whole roll of paper towel. And then we need you to make a graph with your data. You can graph it on your graphing calculator or decimals, whatever. And then we want you to describe your direction, form, and strength. So when we have single variable data, like with our Yellowstone thing, we do center, shape, and spread. But with two variable data, we do direction, form, and strength. So take some time, get your data, and we are going to do, as Brooke said, some inferences off of this, okay? We're going to do some inferences. So let's give you a chance to get some data.
And as you're working, calculator steps are in that same tab. And if you need help, if you just want to holler at one of us or even people in your group.
I can look at your data so we can measure each circumference.
We're just going to talk through just a couple of things here. And one of the things that someone was asking is direction, form, and strength something that that you should start with, like Algebra 1 kids. I don't think so, but I don't know. I don't think that our teachers in our district do. I use the words like center, shape, and spread, direction, form, and strength just as cues to the kids to remember. So if they take the AP exam, or if they're in my stats dual credit, and they're going to go on to stats 217, or just they're going to go on to a degree that's in math, science, whatever. When you have one variable data, usually when they ask you to describe it, they want the center, the shape, and the spread. And when you have two variable data, they want direction, form, and strength. So in this case, your direction comes from either positive or negative. Positive association or negative association. And what did you find? Negative, right? Negative. The more wraps, the smaller the circumference. Form is, what does it look like to you if you had to guess what type of regression you'd use? What does it look like? Linear. Yeah. Does anybody know why it would be linear? Because what? Yeah, there's no square in circumference. Yeah, circumference is a linear measurement. I know for the longest time, I won't even get into it, it'd be too long of a discussion, but it is linear, and the reason being is because of circumference. Strength is that R value, okay? Now, sometimes kids don't know the R value, so they just say, how well do you think that would fit, okay? But that is what we're talking about with direction, form, and strength. Then, we want to talk about a regression line. And so with the regression line, you have a lot of different options, right? If you were with younger kids and you were doing this, they would make their little graph by hand, and they'd probably, we call them spaghetti lines because we use spaghetti that hasn't been cooked. And we just put that piece of spaghetti on there until we think it's about right, and then they choose 2 points, draw the line. Some of you, I think, use median line, which your calculator will give you median line. And some of you, most of you, are at the point where you do a least squares regression line. And so all of you are going to have slightly different data, but your least squares regression lines should be somewhat the same, we hope. And then your calculator will also give you your R and your R squared. What would be a perfect R for this situation? -1. Nice. -1. Usually my kids will go 1 and I'll look at it. -1. Okay, because it's a negative association. So did anybody get R values? Yeah. How close were you to 1? Were you?
Yeah, -9.5 or
9.877. Yeah? Everybody's pretty close? Good. Okay. Does anybody know what R squared is on your calculators?
It's the percent of data that fit, right?
The coefficient of determination, you have it exactly right. What percent of the data of Y would fit given the least squares regression line of Y on X, okay? So that tells you kind of, most people stop at R, but with the coefficient of determination, you can go a little bit further, can't you? Okay, so it would be, so what is your R squared here?
0.99756.
Okay, so 99.8% of the variation in circumference can be explained by the least squares regression line of circumference on number of graphs.
Right.
Okay? Yeah. Okay,
Within
so
the
that, pardon?
Is that probably within a 5%?
You know, I don't know the answer to that.
Because that's the
I just
standard,
always
right?
do it, I just do it as that percent, and I don't ever talk about a margin of error on that. Okay? Yeah, let's stop it there, and then, go ahead, Ellen.
So the next question, so you've gathered data, you've created a graph, you've made a line of fit. The question I'd like to ask you is, how many wraps are on your paper of towels? Are on your roll of paper towels? I haven't been sleeping much lately. How many wraps are on your roll of paper towels? So if I unwrap this whole thing, and I counted them down, how many wraps are on this thing? So, at your table with your group, I want you to figure out how you figure that out. What information do you need? Do you have it? Can you do it? Based on... And then do it! You have 3 minutes! Thank you.
Okay, you scrunched your nose and right. So let's do that. So let's do the entire, let's do the whole thing. Let's take the diameter.
morning, so they have to take a couple of them and then get out there and we're looking into that process.
So this is part of the why.
But that's not true to our situation because of the fact that the south pole is red. We actually need to know.
So I will say, I think if we don't, if our center right now is thinking about all of this, the first aid kit, it will calculate it from here within the so what we have to do.
Don't cut me.
Right. That would be our job, to say this is our social.
Yeah, we get a negative answer. That doesn't make sense. We're finding and the percentage is correct.
Well, why don't we get the full answer and measure off this?
Well, it's gonna get the whole diameter.
I know, but should we rewrap it?
No, I'm just listening.
You got really excited.
I did get really excited.
I was like,
It would make sense to like take our time and subtract how much we have after we unroll it in half.
Because that was just, it's all the way across the board, just going for the radius.
Yeah, you know what I mean? That's off, so really take
So I need to know what
So if we want to, 13.5 is the radius. So we want to know when we have a circumference of 13.5. We want to know.
60 seconds!
Okay, I can.
Okay, but our circumference, they think we're
Here, I have it written down, 6, 9, 12 times 5. So I said, she changed it.
okay, so 12, okay. Yeah, 37.
Divided out by -0.42.
So it should have been actually.
But you can't put that in. Why?
Because that was the circumference of the.
I guess, yeah, we could actually.
So we don't want it to circumference of the we want it to go down to where the zero is.
But it wasn't 15, it was a
Yeah, that's when we get to the hole.
We're not just going
Yeah, 13.5, yeah.
you're going to divide 4 by 3. You're going to divide 4 by 3. Or space that you're going to how many wraps.
I don't know how much you get fired to go from the 37 to 13, right? That's what we're trying to figure out, how many wraps go.
Which is the difference. So how many wraps go on 24?
Yeah, that would actually, it's not very clear, yeah.
Changing the way, so why is this? If the change in circumference per unit is 1.9,
Yeah, I think that is correct.
and there's 60 wraps, we should be able
We
to
got
find.
the very,
We should be able to find.
I said,
Add.
Because this is, I don't know what to do, it's because the way.
right,
No, it was just
we're
around
one
one
time.
wrap.
If I put in 6, it's
feed yourself in a restaurant or eat at McDonald's.
So really, one thing is actually so interesting is we don't subtract, is actually we wanna know where that's at
Oh, you're checking.
by the time we get to the center. What is the measure of
Well, we
that?
could use
So we have the correct answer for that graph.
Okay, all right.
That's really how we graph.
You have 3 seconds. I want to answer how many wraps do you think are on a roll of paper towels? First of all, what did you have to measure to figure this out?
Center.
The center. The center.
Look at that.
The center. What do you mean the center?
You paper towels run out.
Sorry?
When the paper towels run out.
When the paper towels run out, you still have a circle. Yeah. You don't have to go to the very center. You don't want to know what it is for 0, because that's not what a paper towel roll is. It doesn't go to the middle. It goes to here. So this is your circumference, which is
13.5.
13.5 centimeters.
Oh, 1 centimeter.
Good, all right. Or such and such inches if you're using inches. All right. You plug that in for y, and you solve for x. Good. So I just want to do a quick once around. What's your prediction at your table? Starting with Mariah's table. 50. 56.
Depends on what our
60.
paper towel roll was and those things.
49.
You messed up.
You missed it. 54. All right.
Oh, I kept getting that too.
How do you figure it out?
You just have to do it in the middle.
You have to count it, right? Yeah. You have to go and count it and figure out. If I said to you, how would you make your data better? How would you make your prediction better? How would you be more comfortable with your prediction? Rather than going, 54, how the hell did you figure that out? I don't know, I guess. What would you say? More data! You always want more data. You want more time, you want more data. All right. So, good. What else can we do with this? This is a neat problem. There's a lot of information on your wrapper, right? Yeah. Yeah. Sorry, go ahead. Sorry, Terry's got something for you.
Okay, so from the number of wraps then, can you predict how long your roll of paper towels is? What would you do? Sorry about that. So how would you find the length? How would you find the length on there? Because you just have the circumference, right? And it's different every time. So you need your average circumference, right? Where would your average circumference be? In the middle of the wraps. So if you had 50 wraps, go to 25, find that circumference, multiply it by 50, and boom. Okay? Do you know another way that you could do this? Does this remind you of anything else? As you looked at your data points, does it remind you of anything? Algebra 2, recalc.
I think it's summation.
Yeah, summation is what? Series and sequences, right? So what is it?
Arithmetic.
Arithmetic.
Oh, I think that's
Arithmetic, yeah, and so from arithmetic you can go on too, can't you? Yeah. And so I think that there's, if you take the outside of the package and you look at the area and the number of sheets and all of that, I think you can do some kind of cool things with it.
This one, in case you're like, I have to know, has 62.
62 wraps?
62 wraps.
There we go.
There you go. All right, we are out of time. I'm coming over there. All right. One thing that we noticed as you start to look through your standards is that stat standards are in every year in Appendix A. There's not a stats year. You're expected to teach it every year. You're expected to teach some stats in Algebra 1 and Algebra 2 and Geometry. Integrated 1, 2, and 3 makes more sense to me. It's kind of come out of natural. But you are expected to teach statistics in here. And so, just keep that in mind. We don't have time to go looking right now.
You want an online module?
Yes.
Stats is one of those things that is usually at the end of the book.
It's like geometry, it's at the end of the book. You don't get
That's
it.
geometry.
Yes? Yes.
I don't teach geometry, can someone remind me how you find the center of a circle using construction?
Yeah, so you take two chords.
Perpendicular by the circumference.
Yeah, but guess them. So I wanted to understand.
Perpendicular bisectors of two chords.
That's what I thought.
So that would be our.
And where they intersect, yeah, we use
Would you like to use the circle?
All right.
Drawing two lines.
Anyway, thank you very much. It's been a pleasure. You smell great. And,
Oh, wait.
I did. There's references too if you're interested.
this will all be in your digital portfolio.
So some of you were asking about some of the
So you
names
get
and
straight.
stuff, Brooke has it all listed up there.
Yeah.
And do you have a break right now?
Yeah.
Yes,
Well,
I
that'd
do.
be nice.
Okay.
Yeah.
So that'd be nice. Yeah. We've been talking for a long time.